Hello and welcome to Organic Chemistry. Lewis structure. This is where we use dots or small circles or an X to donate electrons that are used for sharing. So for example, hydrogen that has a Z value of 1, that means it has 1 electron and 1 proton. So if we look at the number of electrons, it's 1, and therefore we write it as hydrogen H with a dot, or H with an X. To describe the bonding of hydrogen molecule H2, you see that you have two hydrogens, and then we can use an X to donate 1 electron from the first hydrogen and a dot to donate the other electron from the other hydrogen. And we see that if you look at the number of electrons around the first hydrogen there, we'll see that we have 1 and 2, and therefore it becomes a duplet. And duplet is where you gain some stability by having 2 electrons on the outer energy level. Next, we look at water, H2O. We see that it has oxygen with a Z value of 8, therefore it has 8 electrons. And the valence electrons, that's the electrons on the outer energy level, is 6. And therefore oxygen is in group 6A. And therefore oxygen has 6 valence electrons. And therefore we write the 6 electrons as pair there and another pair there. That accounts for 4. And then we're left with 2, and we spread them out like that. And then it's bonding to 2 hydrogens. So we write 1 hydrogen here and the other hydrogen on this side. And then we show the electrons that each hydrogen brings or contributes to bonding as a dot. And therefore we end up with that as a bond where you have 2 electrons between hydrogen and oxygen, with 1 coming from oxygen and 1 from hydrogen. And then the same thing on this side. Therefore, they satisfy what we say is a duplet. But for oxygen, if you count the number of electrons around oxygen, then we have these 2, we have that 2, we have another 2 from that pair and another 2, and that gives you a total of 8, and that results in what we call an octet rule, which states that molecules gain stability, or atoms gain stability, by having 8 electrons on the outer energy level. And in order to do that, they end up sharing electrons, and therefore you end up with 8 electrons. So octet rule says that stability is attained by having 8 electrons in the outer energy level. And then the duplet rule says 2 electrons. And for duplet rule, it's only hydrogen and helium that satisfies that. All the other elements in the periodic table will satisfy the octet rule. Next, we look at the valence shell. This is the outermost energy level. And the valence electrons are the number of electrons in the valence shell. So that's the outermost shell. That means the electrons that can be used for bonding. Valence, on the other hand, means the number of bonds that's formed by that atom. So for example, hydrogen has a valence of 1, oxygen has a valence of 2, and we'll look at others later. So if you look at atoms here, and then we have the number of electrons on the outer energy level, we're using Z because Z equals to the number of protons, and in a neutral atom, that equals to the number of electrons. So for oxygen, it has 8 electrons. That's the number of electrons. But the valence electron is 6 because oxygen is in group 6A. Also, if you write the electron configuration for oxygen, it will be 1s2, 2s2, and 2p4. So you'll see that the outermost energy level, the level 2, has 2 and 4, giving you a total of 6 electrons. And then valence is the number of bonds formed by oxygen. We see that oxygen has 6 electrons. In order to attain an octet, that means you need to have 8 electrons. Therefore, it needs to form 2 more bonds, and therefore it has a valence of 2. Potassium, on the other hand, is in group 1. Then the number of valence electrons is 1, and its valence is also 1, because metals would prefer to lose electrons to form a positive charge, and you end up with a +1 charge. Lithium is in group 1 also. So it has 1 valence electron, and same as potassium, it will form 1 bond and +1 charge. Oxygen that we just looked at can accept 2 electrons, and because of that, you end up with -2 charge. Sulfur is in the same group with oxygen with 6 valence electrons, and therefore it will form 2 bonds and -2 charge. But because sulfur has d orbitals, you get to situations where you can actually have 4 or even 6 bonds on sulfur because you get what's called an expanded octet. Nitrogen is in group 5. That means you have 5 valence electrons, and because you have 5, you need 3 more to form an octet, and therefore to form 3 bonds, and you end up with a charge of -3. Phosphorus is in group 5 just below nitrogen, and therefore you end up forming 3 bonds and a charge of -3. But just as we saw with sulfur, with phosphorus you have empty d orbitals, and because of that you can have expanded octet, and therefore you end up with either 3 bonds or even 5 bonds. And that's why you will see things like PCl5. Boron is in group 3, so 3 valence electrons, and because of that it forms 3 bonds, but you realize that it doesn't satisfy an octet, because if you have 3 bonds, each of those with a maximum of 2 electrons, so that comes to 6 electrons, you're still missing 2 electrons to form an octet, and because of that you have what we call a hole. And because of that, boron compounds, so for example BH3, are Lewis acids because they can accept electron pair. Carbon is in group 4, has 4 valence electrons, and because it has 4, it would take the same amount of energy to lose 4 electrons or to gain 4 electrons. Because of that, carbon would prefer to share electrons, and therefore you end up with covalent bonds, and you end up forming 4 bonds. So we say carbon is tetravalent as it forms 4 bonds. Chlorine, group 7A, has 7 valence electrons, and because of that you only need 1 more bond to form an octet, and therefore it will form 1 bond, and the charge will be -1. So we already covered charges. Group 1A forms a charge of +1, group 5A charge of -3 because you need 3 more electrons to form an octet. Group 7A, we just saw chlorine for example, has 7 valence electrons, and therefore you need 1 more electron to form an octet. Group 8A has 8 electrons, and because of that there is no charge. In fact, group 8 compounds are called inert gases. They're stable the way they are. They're not easy to react, group 8A, with other elements in the periodic table. The other type of structure is called Kekule structure or line bond structure, and that's where we use lines to replace bonds. So it's similar to Lewis structure, but now we replace the bonds with lines. Remember, in Lewis we are using electron pairs. Now we show the lines, but we still need to show the non-bonding electrons. So for example, hydrogen, H2, instead of the 2 electrons between hydrogen, now we just use a line between hydrogen. Water, we'll have a line between hydrogen and oxygen, and then we're left with 2 electron pairs. That's 4 electrons on oxygen, and we need to show those. So oxygen has 2 electron pairs. Remember, the Lewis structure for water was written like this, and we were using electron pairs instead of the bonds. Thank you very much for your time. If you enjoyed the video, like this video to support the channel, and also subscribe.